Welcome to another edition of 101 Ways to Have Fun with a Whiteboard. Episode 2, Draw all of the isomers of hexane. That sounds like fun. So, how do we start? Well, remember, hexane has the general formula of 2n plus 2 hydrogens. So, let's start out by drawing the straight chain. 1, 2, 3, 4, 5, 6. Here's our 6 carbons. Now we need to add our hydrogens, so each carbon has 4 bonds. 1, 2, 3. And these are now our CH2 groups. And of course, that is hexane. Okay, so how do we systematically go about drawing the isomers of hexane? Well, obviously, if we're going to start putting alkyl groups in there, the smallest alkyl group we should start with is methyl. That removes 1 carbon from the chain and leaves us with 5 in the main chain. So these now all become pentanes. So let's start off with the first pentane isomer. So I'll start by drawing 5 carbons. There's our pentane chain. Now, if I place the methyl group on the last carbon, or the first carbon, then really I'm just redrawing our first isomer. So I have to be sure to at least put it on carbon number 2. So there's our alkyl group, 1 carbon, so it's a methyl group. Let's draw our hydrogens in. Now, when you're drawing these structures, be sure not just to leave a line there. If you leave a line like that, it implies that in fact we have a carbon bonded to another carbon. Be sure to put the hydrogen in. So let's put all of those hydrogens in for our full structural formula. And now we have an isomer. Same formula, if you add up all the hydrogens and carbons, it adds to C6H14. Let's name it. So 1, 2, 3, 4, 5 carbons in the longest chain. It is indeed a pentane. Remember, the ANE denotes that it is an alkane, but we have to say where the alkyl group is now. So we write 2-methyl pentane. Hopefully that's in shot. Okay, next isomer. So let's move this methyl group to the next carbon, carbon number 3. So 1, 2, 3, 4, 5. Put this under carbon number 3. And we compare it to the other 2 isomers, and we see that it is in fact structurally different. There's no way we can rotate this around without breaking bonds to get either the 2-methyl pentane or indeed the hexane. Professor Harry, what do you think? Does that look correct to you?
No.
What do you mean no? That's 2-methyl pentane.
What? I'm near 3. I'm not supposed to know.
That's 3 there. So let's write it in, Harry. We write it 3. 1, 2, 3. 3. We have 1 carbon in the alkyl group. It's a methyl again. And 5 carbons in the main chain. Methyl pentane. Okay. Thank you, Professor Harry. Off you go. Off to bed. Off you go. Off you go. Oh dear, it's a madhouse here. So, 3-methyl pentane. Are there any more isomers we can draw? Well, certainly not for pentane, because if we move the alkyl group another carbon along, we could say 1, 2, 3, 4, but we can just swing that around 180 degrees. In fact, it's back at the 2 carbon. So, in fact, it would be identical to 2-methyl pentane. Okay, can we shorten the chain? Let's try that out. So I'm just going to rub out these bottom ones because, oh no, I can draw over here. This is such a big whiteboard, so much fun to be had. 1, 2, 3, and that's still in shot. So now we have a propane chain, 3, and now we can muck around with alkyl chains. If we put an ethyl group here, now I'm not going to put oh, that's my cat Millie, out of the way. Thank you, Millie. Right. Now, if we have an ethyl group, all we're really doing here, and I'm not going to put the hydrogens in for the moment, is I really have just drawn a bent hexane chain, so it's not an isomer. Let's get rid of that. Okay, if I put a methyl here and a methyl there, again, all I've done is drawn a hexane chain. I've just bent it, which can happen because there's free rotation about these single bonds. So that doesn't help. So are there any more isomers of hexane? We've got 3 to begin with. Let's see, what if we put 2 methyl groups on the same carbon? Now in this case, we've got 1, 2, 3, 4, 5. That kind of works, that's a new shape. But of course, we need another carbon to get to C6. So, let's stick with a 4-membered chain, a butyl group. Let's put our hydrogens in and see if we get our isomer formula of C6H14. Okay, so 1, 2, 3, 4. Is that the longest chain? Well, you need to double check. 1, 2, 3, 4. So yeah, 4 is our longest chain, so this is definitely going to be an isomer. 1, 2, 3, 4, 5, 6 carbons. Add all the hydrogens up, it does add to 14. So indeed, we've got another isomer. What can we call this, however? Now when we have 2 alkyl groups on the same carbon, we have to number both of them. So this will be 2, 2, stroke, and then because there's 2 of them, we need to say dimethyl. Di meaning 2, just like when we're naming covalently bonded substances. So 2-methyl, and the longest chain is a 4-membered chain, which means it's butyl, or butane. So 2,2-dimethyl butane. All right, are there any more isomers? Is there any more fun we had with the whiteboard tonight? Well, there is indeed, fans. So let's go for a butyl chain again. 1, 2, 3, 4. But this time, we're going to put 1 methyl group here and 1 methyl group here. I'm just going to write these shorthand because I'm running out of room. Okay, now let's check for the longest chain again. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3. So that is correct, it's a butane. And this time, both the methyls on 2 different groups. I'm going to give you a moment to name that. Press the pause button while you're doing it, and when you've unpaused, I'll give you the answer. Okay, you've unpaused. The answer will be, we name, doesn't matter which end we name from, because we're going to see that this rotates around. 1, 2, 3. So we're going to have a 2, 3 dimethyl. If we go from this end, it's still 2, 3 dimethyl. So the answer is 2, 3 dimethyl butane. And they're the 5 different isomers of hexane. Well, I hope you've had fun with the whiteboard tonight. And while we're all under lockdown with coronavirus, there's lots more fun to be had. See you soon.